All right, calculator section here. PSAT Practice Test 2019. Let's get after it. Tyra subscribes to an online gaming service that charges a monthly fee of $5 and 25 cents per hour. Which of the following functions gives the cost for a month if you spend X hours? So the monthly fee does not matter how many games she plays. So that's kind of the constant. That's the standalone price. Play 0 games, play 1,000 games, it's $5. The 25 cents per hour, so I have 25 cents times per hour means times every hour. Hours are X. So this is going to be the cost here, and this is just function notation. So which one of these matches this? Looks like they have it a little bit backwards. The correct answer there would be C. Number 2, a grocery store sells a brand of juice in individual bottles and in packs of 6. So let me just kind of draw this out. We could have an individual bottle there, or we could have a pack that's got, I'm just kind of make this fast, pretend these are bottles of 6. On a certain day, they sold 281 bottles of the brand of juice. 29 were sold as individuals. Which equation shows the number of packs? So if I have my 281 total bottles and then I subtract the 29 individuals, right? So subtract 29, you get, it's at 252. And then I would take that 252, and to find the number of packs, I would divide by 6. So I could find the answer. Over here, it doesn't really show the answer, but it kind of shows expressions. So let's just kind of look and see what I did there actually. So the first thing I did was 281, subtract the 29, and that told me how many were left. And then I divide by 6, because that's how many packs there are, and that should give me the answer, which is A. Now I could actually verify it. 252 divided by 6. So 6 goes in there. It looks like 42 packs. So even if I could just get to the answer of 42 packs, I could go over here and I could test every single one of these and made sure which one give me the answer of 42, which should be A. The other ones won't give you the correct answer of 42. Number 3, I have a rainfall question here with a graph. So it says the line graph above shows the monthly rainfall from March to October in Chestnut City. According to the graph, what is the greatest change in the monthly rainfall between any 2 months? So basically, like, here's the change between these 2 months. It basically dropped 1/2. So it went down by 1/2. This one right here represents an increase of 1. Right here, it dropped by 1/2. Here was an increase by 1.5. And looking through, it looks like the biggest change was right here. Every little grid's worth 1/2. So it looks like we dropped 2.5 inches from September to October. So correct answer there is C, the greatest change. All right, number 4, a rectangle has a perimeter P, length L, width W. Which of the following represents L in terms of P and W? So they use this expression a lot, in terms of. So that just basically means that they want you to write it as L equals a bunch of stuff. So we got to set up an equation, then solve it for L. So let's talk about this. We have a little rectangle. I'm going to call this my length, this my width, this my length, this my width. Perimeter is add up all the sides. So the perimeter would be 2L's plus 2W. A couple other ways you could write that, but that's one way. And now I just got to solve this for L. So basically I'm trying to get this variable all by itself. So the first thing I'm going to do is I'm going to get rid of the plus 2W by subtracting 2W from both sides. So when I do that, I have P minus 2W equals 2L. And now to get this L all by itself, this is multiply 2 times L. So the inverse or the opposite there is to divide by 2. Divide by 2. And now I have L equals this stuff, which looks like the correct answer is right here. C. Now, another way I want to show you that you could do this if you're not very good at algebra is you could just kind of pick some numbers here. So let's say that you make your own rectangle, and let's just say that it's 4 by 3 and 4 by 3. So our length is 4, our width is 3, which will give us a perimeter if you add up all the way around. 3 and 4 and 3 and 4 is 14. You could then go through these equations over here and plug in L equals 4, W equals 3, and P equals 14, and see which one checks out right math-wise. So for instance, if I plug this into number 1, if L is 4, and P is 14, and W is 3, that's a false statement. 4 is not equal to 14 take away 3. So A would be out. When you try the next one here, I would rewrite, like let's say I'm going to try B. I could write that in and I could say, hey, 4 equals 2 times 14 minus 3, all divided by 2. And if I try that one, I will get 28 divided by 3, or minus 3, which is 25, divided by 2, which is not equal to 4. So I know that this one is incorrect. I could then try it again. Now this way is longer, but if you're in a pinch and you're not very good at rearranging terms, you just got to roll with it. Try this one right here. This would be L equals P minus 2 times W, all chopped in half. So that's 14 take away 6 chopped in half, which does come out to be 4, and 4 equals 4. So I would know that this is the right equation without doing any algebra. I basically just picked my own numbers. All right, number 5, looks like we have a system of equations. One of the most common type of questions you're going to see on the SAT. I look at it and it's lined up to where I have my x's are lined up, my y's are lined up, and my constants or my numbers are lined up. Usually the best method here is to use elimination. So I'm going to try to get the coefficients to match up on either x's and y's. I think if I multiply this entire bottom row by 2, I'll get things to match up. So my top row I'm not going to change. 2x minus y equals 6. My bottom row, I'm going to basically distribute that 2 all the way across. So I have 2x plus 4y equals negative 4. And now what I can do is, it's my choice to either add or subtract. I'm going to subtract because I want to eliminate the x's. So 2x minus 2x disappears. Now when I'm doing this y column, I got to be careful because I have a negative 1y take away a positive 4. So be careful there. That's really a negative 5. So I have negative 5y equals, now I have 6 subtract negative 4, which ends up being 10. And now to solve this, I'm going to divide both sides by a negative 5. Boom. I get y equals negative 2. So now I'm going to run through and I'm going to check. Remember, these are x's, these are y's. There's only one with a negative 2 there. And that's the answer of C. Now, if there was more than one, I would then have to take this negative 2 and substitute it back in to one of these two places just to verify the x part. So I'll do that just to show you really quick. So x plus 2 times a negative 2 equals negative 2. So I plugged it into this equation. And that'll be x minus 4 equals negative 2. Add 4 to both sides. And I get x equals positive 2, which is in fact right there. So I know my answer is good. All right, number 6, a soda company is filling bottles of soda from a tank that contains 500 gallons of soda. At most, how many 20-ounce bottles could be filled? Then they give us a nice little conversion here. So I'm just going to kind of draw this giant drum, which is 500 gallons. And the first thing I probably want to do, since we're trying to fit this into, some sort of 20-ounce bottle, and we want to know how many of these can go in there, let's change gallons into ounces. So if 1 gallon is 128 ounces, 500 gallons, I just multiply by 128, and that'll give me 64,000 ounces. So that's a giant drum, 640,000 ounces. And now to figure out how many of these can go in there, I just need to divide. So really 2 goes into 6432 times. Got a couple extra zeros here. So 3,200. So in your calculator, you'd enter 64,000 divided by 20. All right, moving on to number 7. A car traveled an average speed of 80 miles per hour for 3 hours, consumed fuel at a rate of 34 miles per gallon. How many gallons did the car use for the 3-hour trip? All right. Well, there's a lot of different ways to do these. I kind of always go to my distance equation. So, some people, depending on how you write it, I like just calling it the distance equation because it's DST. Distance equals speed times time. So this is your speed, this is your time, and this is the distance. And there's ways to rearrange that to get whatever variable you want. So I'm going to put in what we know. We knew our speed was 80 miles per hour, and we knew our time was 3 hours. So I kind of just put those in there. So the first thing that I have to realize is that the distance is 240 miles. So I traveled 240 miles. And there's a few different ways to do this one. You could set up a ratio, and you could say, if I have a rate of 34 miles per 1 gallon, that means I can do 34 miles for every 1 gallon of gas. So I can go 240 miles, and how many miles, or how many gallons of gas? So you could cross multiply here if you wanted to. You could do 240 equals 34 times x, and then just solve it. Now you may have noticed earlier, you may have just seen that, I can just divide 240 by 34. That would have been probably a little bit faster. But either way, you're going to get 7.05, and it's like the correct answer there is D. All right, next problem is number 8. Kind of cut off my screen there. Number 8, what is the slope of the line that passes through the points -5/2 1 and -1/2 4? So remember, this is x and y, and we'll call these the first order pair, and x and y the second order pair. So, officially old school is to find the slope, you're basically subtracting the y's and subtracting the x's. A lot of people call this rise over run, which works better if you have a graph, but we really probably don't have time to graph this thing out. So I kind of always just do it old school like this. This is my y2, so I go y2 minus y1, so that's 4, take away 1. And then my x's, I always write this arrow on the bottom just so that I remember it goes on the bottom of the fraction. So -1/2 subtract, be careful here, -5/2. Sometimes people forget the extra negative. And I crank this out. I get 3 over, minus a negative is really plus. So -1 plus 5, that's 4/2 here on the bottom, which is actually 2. So my slope is 3 over 2. Correct answer D. Now another way that you can do that, kind of a newer school way, I wasn't taught this way, but some kids have showed me this, is you can stack them up. And some people call this a slope slide. So the slope slide just kind of organizes it a little better and lets you know what goes on top. So some teachers do it like this. You kind of come down, then you slide. And now I just do my subtraction. 1 minus 4, -3, -5/2. Take away -1/2. Add the opposite. And you get the same thing. You just get -3 over -2, which negative divided by a negative turns out to be positive. I don't know. It's a little bit more work. It's the same concept. It just kind of forces you, the slope slide forces you to put your y's on top. All right. Number 9. We have a graph here. Dimensions of envelopes, height on the left, width on the bottom, some sort of scatter plot. Shows the width and height of 12 types of rectangular envelopes. What is the width in inches? So we're focusing here. What is the width in inches of the envelope represented by the data point that is farthest from the line of best fit. And I was a little confused the first time I read this, but when they say not shown, they're referring to the line of best fit. So the line of best fit's the one that kind of goes through roughly where the dots go. So let's just kind of, maybe something like that would be a good line of best fit that tried to hit most of the dots. And the point that I noticed that is the furthest from the line of best fit is this dude right here. And what he represents a width of 7, and he represents a height of 4. But they want to know what is the width. So the correct answer here is 7, C. All right, number 10, a high school basketball team won exactly there, 65% of the games it played last season. Which of the following could be the total number of games the team played? Well, this word percent means per 100. So 65%, another way to express that is 65 out of 100. And I'm basically trying to figure out what number could go here. And looking through, it looks like none of these numbers here could go in this box because they don't go into 100 evenly. So I think the only answer here that makes sense would be 20. Because if I wanted to reduce this down, if I divide by 5 and divide by 5, that would be 13 wins out of 20. None of those other numbers would work because you're going to end up getting a decimal when you try to divide. All right, number 11. I have an equation there. It says a coffee shop is running a promotion where a number of free coffee samples are given away every day. The equation above can be used to model the number of free samples, Y. So these are the free samples that remain to be given away X days. So this is days, and Y is the free samples that remain. So the free remaining samples. And they want to know, what does it mean that 11, 0 is a solution to the equation? So 11 is the X. So that's the days. 0 is the Y. So that's remaining. So it sounds like when there are, after 11 days, there are 0 coffees remaining. So let's see if we can find that. During the promotion, 11 given away each day. No. It takes 11 days to see the customers. We don't know about that. It takes 11 days during the promotion until none of the samples are remaining. I believe this is the correct answer because this is our 0 samples remaining, which was Y. X is the days, which was 11. So that makes sense. Correct answer is C. All right, number 12. Which scatter plot shows a negative association that is not linear? Negative association which is not linear. Well, you know, this one is linear. There's an association. It looks like it forms a pretty nice line. So this is negative, okay, but it is linear. So that kind of knocks that one out of there. Part B, this one is negative because it's trending down to the right. You know, that's the negative part. And it kind of looks like it's forming some sort of curve like this. So I believe this one is the negative nonlinear. This one right here, it's kind of going in both directions. It's negative until we get to 10 and then it starts increasing. And this one down here, dots are everywhere. So this would be no correlation. So correct answer for this one is B. All right, number 13, we have a histogram here, and my PDF didn't come through with the best quality of copy, so I'm going to kind of dress this up a little bit using some color. So on the actual document, this is what was shaded in. You can kind of just barely see it, but I'll just kind of do this so it's a little bit easier for us to see. You have that one, you have this one, and then over here. So that's what the actual test that they released. And if you look in the download, you'll kind of see that. Hopefully it'll come through a little bit better for you. But let's check this out. So we have 26 pyramids in Egypt. These represent the heights. So it looks like the tallest pyramid's over here at 150. I got to make my line a little bit less fat here. So let's go back to here. There we go. So right here, this little histogram right here means that there were 2 pyramids between 15 and 30 feet tall. My kids kind of struggle understanding that that represents 2 different pyramids. You know, here we're talking about there's 3 different pyramids. There are 12 pyramids, so a lot of pyramids in between 45 and 60 feet tall. There are 4 pyramids between 60 and 75 feet tall. There was 1 pyramid right here in the 75 to 90. There are 2 in the 90 to 105. And then there are 2 in the 135 to 150. So basically, hopefully this adds up to 26. You know, and I add all these together. Hopefully I have 26 pyramids. 5, 17, 21, 22, 23. Yep, 26. Now, the key to this one is, it says, what about the median height? Well, the median, remember, is the middle. All right? It's when you line them all up, it's the middle. So if we line these things up in order from shortest to tallest, the middle number, well, since we have an even number, there's a bit of an issue. The middle number is going to come between the 13th and 14th pyramid. Basically, you can just divide that number kind of by 2. So there's 13 on one side, 13 on the other, so it'd be right in the middle of those 2. Well, let's see where that would occur. So there's 2 here, there's 3 here, we're up to 5. Well, now after this one right here, that's 17 pyramids right there. This batch right here is 17 pyramids. So the 13th and 14th pyramid is going to occur in this interval. So it looks like we need to find a number between 45 and 60. So the correct answer there is 48. So our middle pyramid, when we line them up by height, is going to be somewhere within that range. All right, question 14 through 16. This is a graph here that kind of goes, or a table that goes with multiple problems. So we can carry this information all the way through the next 3. So we got a survey of 170 randomly selected teenagers, age 14 through 17, talking about employment. So if we focus on this row right here, those are the 14 and 15-year-olds. 20 have a job, 69 don't, for a grand total of 89. This horizontal row are all the 16 and 17-year-olds. You know, 39 have a job, 42 don't, for a total of 81. And then you can also total them up coming down. So you can just look at kids that have a job. You know, 21 plus 39 gives you a total of 59. And 69 plus 42 is 111. And then one of the more important boxes typically is this corner box, which basically tells you the total number in the entire survey, which if you add vertically or horizontally, it should come out to be that number. So kind of keep all that in mind as we work through these. So 14, which of the following is closest to the percent of those surveyed? So this is huge. Whatever comes after the word of, that's going to be your bottom number. So of those surveyed, so we're talking about out of everybody, okay, what percentage of those surveyed had a summer job? Well, all the kids that had summer jobs are right here in this box, okay? So 59 out of 170. Now to change that fraction to a percent, you know, this just means divide. So I'm going to do 59 divided by 170. Pop this in the calculator. 59 divided by 170. And I get 0.3470. That's probably enough. And then you got to times by 100, which actually just means move the decimal 2 places. So we're looking at about 34.7%. So B is going to be the closest answer there. Number 15, the next part of this problem, I kind of had to zoom out a little bit so that we could still see the table and the question itself. So in 2012, the total population of individuals in the U.S. who were between 14 and 17 was about 17 million. All right. So between 14 and 17 years old, we had 17 million. So that's 17 with 6 zeros after it. If the survey results are used to estimate information, so that means if we use these results up here to estimate the information and kind of apply it to a bigger population, what is the best estimate of the total number of individuals between 16 and 17 who had a summer job? All right, so let's kind of do this. Okay, set this up. So this was our survey information, and this is the actual information. And in our survey, we're talking about individuals between 16 and 17 who had a summer job. So 16 and 17-year-olds that had a summer job was right here. So in our survey, 39 out of the 170 kids had a summer job. So I should be able to, if it was a valid or a reliable survey, I should be able to apply it to a larger population and find out how many kids out of the 17 million. Now this is kind of a nice one. You know, I could cross multiply if I want to. I could do that. But I kind of noticed right here that to get from 170 to 17 million, you're basically just adding 5 zeros. All right. So we just got to kind of blow it up a little bit bigger and add 5 zeros. So this is going to be a 39 with 5 zeros after it, which is going to give me the correct answer of B. So again, you could multiply with your calculator, but it might be faster if you kind of just scale it up by, you know, it looks like we multiply by 100,000 there. All right, number 16. This one, when I did it the first time, and actually a couple other teachers did it, we kind of misread the problem and all got the same wrong answer. But I kind of see now how they wanted to interpret it, but I really don't love the wording on this question. But nevertheless, let's just battle through it. So based on the data, how many times more likely? All right, so that means we're going to need to find the likelihood of two different things happening and then see how many more times, just divide it to see the difference between the two. Is it for a 14, so let's look at this part first, a 14 or a 15-year-old to not have a job? So let's just look at that. Let's look at the likelihood of a 14 to 15-year-old to not have a job. So here are the 14 to 15-year-olds. The likelihood of a 14 or 15-year-old not having a job is 69 out of 89. Okay? And when I tweak that and I change it to a percentage or to a decimal, let me just do this. I'm going to get 69 divided by 89, which is 0.77528 and some other numbers. So somewhere around, let's just call it 77.5%. So that's the likelihood of a 14 to 15-year-old not having a job. Well, now we're going to compare that to the 16 and 17-year-old not having a job. So the 16, 17-year-olds are right here, and 42 out of 81. So we have 42 out of 81, which is pretty close to 0.5. 42 divided by 81 is 0.5185. 0.5185. Or let's just call that, 51.9%-ish. So we have that likelihood. We have this other likelihood. And to find out how many times more likely, we're just going to divide those two numbers. So we're going to go 77.5 divided by 51.9 equals, and I get about 1.49 times more likely. So we're just going to call that C. Now, the answer that most of us chose when we first did it was a lot of us actually chose the wrong answer, which was D. And maybe you did the same thing, so I kind of want to explain how that come about. So we kind of interpreted it as we did the 14 or 15-year-olds not having a summer job. We compared ours out of the total. So we kind of did 69 over 170, which came out to be 0.405. And then we did 42 out of 170 for the older kids. And we got 0.247. And when we divided those two numbers, I think we ended up getting pretty close to 1.64. Now, this was wrong. This was not the correct way to think about it. But if you got that answer, that's probably what you did. You probably compared the likelihood of them not having a job to the total population instead of each their own. All right, number 17, percent protein in 5 food products. So let's take a look here at what we got. The graph above shows the amount of protein supplied by 5 different food products as a percentage of their total weight. The cost of the 10 grams are the following, and they have each one. So this is, A, B, C, D, and E. Which of the 5 food products supplies the most protein per dollar? So what we're looking for is we're looking for the protein per dollar. All right? And it's 10 grams for all of them. So let's go through here. Let's look at A. So first of all, point A, you're getting 10% for $2. So 10% for $2. B, we're getting 15% for $2.20. C, we're getting 20% protein for $2.50. D, we are getting 25% protein for $4. And then finally E, we're getting 30% for $5. So now what you got to do is you got to go through and you got to divide all these out. So it looks like for A, this one is, you're getting 5%. 15 divided by 220, this would be $6.80. And C, 20 over 25, that's 8. So you're getting 8% per dollar. Part D, you're getting 6.25. And then this one is just 6. So it looks like out of all of those, C is the best buy because you are getting 8% for every $1 spent. So the correct answer there is C. And it looks like they didn't even have D, so we didn't really even have to do that one. All right, let's go over here. Let's go to number 18. So I'll give myself some room to work. So we have a trapezoid. It looks like a trapezoid. Quadrilateral above. BC is parallel to AD, so yeah, it's a trapezoid. The two sides are congruent, so it's isosceles. If BC and AD were each doubled, and BE, which is the height, was reduced by 50% or chopped in half, how would the area change? So I think what I'm going to do here is I'm going to just make up my own numbers. I'm going to put a 2 in for this one, and I'm going to put a 4 in for this one, and I don't know, let's just say that the height is 2 also. So the area of any trapezoid in general is you add the bases and divide by 2. Basically, it's the average of the bases. And then you multiply by the height. So it's kind of like a rectangle. It's like base times height, but it's the average of the bases. So let's find the area of this thing. So we have base 1, which is the top, added to base 2, which is the bottom, chopped in half, multiplied by the height. So 2 plus 4 is 6. 6 divided by 2 is 3. 3 times 2. So I have an area of 6 for my trapezoid. Now let's do the one that they want to make some modifications to. So it says BC and AD are doubled. So I'm going to double this one, and I'm going to double this one. And BE is reduced by 50%, so it's chopped in half. So let's run it back again. Let's run back the new area. And we have base 1 plus base 2 divided by 2 times 1. Well, that's 12 divided by 2, which is 6 times 1, so 6. So it looks like it did not change at all. So the correct answer there would be C. All right, let's keep on moving. 19. So Boyd grows tomatoes and raspberries in the garden. Last year we had 140 pounds of tomatoes. So tomatoes, we had 140 pounds. Raspberries, we had 60 pounds. This year, production by weight of tomatoes declined by 20%. So if I want to decline by 20%, that means I have 80% of what I did last year. So I'm just kind of coming from a different angle. Now, you could find 20%, which is 28, and then subtract. But that's two moves. It's kind of easier to just come from the other direction and go 80%. Raspberries declined by 50%, so that got cut in half. So by what percentage did the total yield? So we need the percent change for the total yield. So let's figure this out. So if we had 140 pounds of tomato, 80% of that, we take away the 28, that's 112 tomatoes plus 30. So we're at 142 pounds of total yield, where last year we were at 200 pounds. So whenever you, basically the question now is, what is the percent change? Whenever you want to find the percent change, that is defined by the amount of change compared to the original amount, or what it used to be. Some people like to refer to this as new minus old divided by old. You know, so it changed. When I do 200 subtract 142, we have a change of 58 pounds. That's how much we dropped compared to last year's price. Now I could divide this with a calculator, or since it's a percentage, I'm going to just change it and scale it down, chop them both in half. And 29 out of 100 is 29%. So we had a 29% decline. If you were to put that in your calculator, you get 0.29, move the decimal over. So the correct answer there is A. All right, let's keep going down. Number 20. What do we got here? The graph above shows the frequency distribution of a list of randomly generated numbers between 0 and 10. What is the mean? All right, so the mean here means the average. This is the average, so you add up how many things you have and then divide by how many there are. The graph's a little tricky. This frequency means how many times it occurred. So this little bar represents that the number 0 occurred one time, and the number 1 occurred one time, the number 2 one time. We'll keep going. The number 3 occurred 3 times because it was way up here. The number 4 occurred twice. The number 5 did not occur at all. 6, 7, and 8 occurred once. And 9 didn't occur at all. 10 occurred once. So now we got to figure out how many numbers to divide by. Well, that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So we add these guys up. 3, 6, 9, 12. So it looks like 51, hopefully, divided by 12, which would be 4 in a little bit. So C looks like the right answer. That'd be 4 3/12, which is 0.25. So the correct answer there is C. The big thing is knowing how to read the chart and knowing that this frequency means that a number can count more than once. That's kind of the toughest part. All right, let's look at number 21. Number 21, what is the minimum value, so the lowest value of the function, graphed on the xy plane? So we're looking at just x's between -4 and 6. So here's -4, here's 6, which is basically the only part they show us. So here's the function. Well, right there would be the highest point. And it looks like the lowest point in that interval occurs right here, which would be at -2. So the correct answer there is C. All right, moving on up. Ooh, this is a multi-question problem. So we have a graph here with velocity and distance, galaxies. So let's get down here into the paragraph. It says Hubble's day can be modeled by an equation 500D. So let's kind of go into this a little bit. V equals 500D, where V is kilometers per second, and D is the distance in megaparsecs. So we have kilometers, and we have megaparsecs, whatever they are. And then they give me a conversion for a megaparsec, so maybe I'll need that. I don't know. Let's just start seeing what they want us to do. I'm going to shrink this down a little bit so we can see the choices for number 22. All right. According to Hubble's data, how fast? So we want the V, we want the speed. In meters per second is galaxy Q. So galaxy Q is right here. So the speed of galaxy Q is 500. But my units are kilometers per second. So 500 kilometers per second. And they want me to do meters. So big thing you need to know here is that 1 kilometer is 1,000 meters. So I need to multiply this number by 1,000 to get meters per second. And I could times that out on my calculator, but I do notice we have 5 zeros. So this is just 5 times 10 to the 5th represents 5 zeros. So the correct answer there is B. All right, let's go up here to number 23. There are 4 galaxies shown in the graph, approximately 0.9 megaparsecs from Earth. So which of the following is closest to the range of velocities? So the range means the greatest minus the smallest. So that's how you define the range of velocities. And we're looking at 0.9 MPC. So 0.9 is right about here. So looking up, it looks like our range, there's the dot with the greatest, there's the dot with the lowest. So going across, that's somewhere around 650, 700, a little bit below 0. So it looks like D is the only one that makes sense, somewhere about 700 minus 0. All right, number 24, based on the model, what is the speed or the velocity in kilometers per second, so we don't have to convert anything, of a galaxy that's 15 MPCs away? Well, if you notice down here on the bottom, the distance starts at 0, and we run out at 2.5. So 15 is going to be way over there further. So I think here's a good time to use our equation. The velocity is 500 multiplied by the distance, which is 15, and that comes out to be 75 with 2 zeros. So the correct answer there is A. Number 25, Janice puts a fence around a rectangular garden. The garden has a length that is 9 feet less than 3 times the width. What is the perimeter? They give us the area. All right, so let's draw this thing. We're going to draw out a garden, rectangle, and we know what the area is. We know the area is 5670. We have some clues about the width and the length. They don't tell me anything about the width, so I'm going to call that W. The length is 9 feet less than 3 times the width. So there's 3 times the width. There is 9 feet less than 3 times the width. So now I can just use, an equation where I have to multiply the width times the length. So the width times the length should give me the area. And I'm going to distribute here. So I have 3W squared minus 9W equals 5670. I do notice that 3, 9, and these 3 digits add up to 18, so I know 3 goes into there. Let's just divide this entire equation here by 3, just to shrink it down, make it a little bit smaller. So we have W squared minus 3W equals, 3 goes into there, 1, 8, it's like 1890. So now we have a quadratic we have to solve. You know, right now if I had a graphing calculator handy and I could put it up on the screen, I'd probably just graph this to find the zeros. You're going to have one on the positive side. It looks like one on the negative. The negative doesn't make sense. But I assume it's factorable. So to factor this thing, we need to move this number to the other side, set it equal to 0. So we have w squared minus 3w minus 1890 equals 0. And I'm trying to figure out what two factors can make that. I got a couple clues here. I do know that, so I'm going to come back up here to the top. I do know that I need to multiply. So I got to multiply to make negative 1890. This is how factoring works. Then I need to add right here to make that negative 3. So I need two numbers, add to make negative 3, multiply to make negative 1890. So negative 3 tells me they got to be pretty close to each other. So let me just try to multiply like numbers by themselves. So for instance, like I know trying to get close to 1890, I know 40 times 40 is 1600. And I know 50 times 50 is 2500. So my numbers are going to be somewhere between 40 and 50, and they got to be 3 apart. So that gives me a little bit of some clues. So a number I could try, let's just try, and let me kind of get rid of this stuff down here. So I could try a number like 40 and 43, and I multiply those out. Grab my calculator here. 40 times 43. Well, that's 1720, so that's too small. Now I would try 41 and 44, but I know that ends in a 4, so that's not going to work. So 42 and 45, that's going to end in a 0. Let's see what that is. 42 times 45. That's 1890. So good, I got the two numbers. To get them to add to negative 3, I need a minus and a plus. So back to that original thing that I had, the equation I had this going on, and I needed to make negative 3, and I needed to make negative 1890. So it's looking like minus 45 and plus 42 are going to be my combination. I probably could have got that much faster with a graphing calculator and just graphed that parabola. So when you solve this, or actually that was not 1890. Check that. That was 0. So W either equals negative 42, which we can't have a negative width, or W equals 45. So there's our W. So let's kind of go back to this rectangle and see what we have here. So if we have a width of 45 and our length was 9 less than 3 times that. So 3 times that minus 9, that's 135. Take away 9, which is 126. And then now we just got to go back and we got to figure out what the heck the perimeter is. Holy smokes, this one's long. So that's 252 added to 90. That'd be 352. That'd be 342. Whew. Correct answer there is A. Would have been a lot faster with a graphing calculator, that's for sure. Moving on down, number 26. We got some trig here. It doesn't look like it's a lot going on though. So given the right triangle, which of the following is equal to B over A? Well, let's check these out. So we're dealing with sine and tan. So remember, sine is opposite leg over hypotenuse. Tan is the adjacent leg over the hypotenuse. So let's look at the first one. If the sine of A, well, if I stand on A, that would be opposite over hypotenuse, so that's not it. The sine when standing on B would be opposite over hypotenuse, which that's not it. The tangent when standing on A, so tangent when standing on A is opposite over adjacent. Nope, that's A over B. It's got to be this one. Tangent when standing on B would be the opposite leg over the adjacent leg. So the correct answer there is D. All right, moving over here, we're looking at number, I have to shrink this down a little bit, number 27. Maybe I can fit it. So this looks like a system of inequalities where there's shading. One thing I want to kind of remind you on is an easy way to shade. So first let's check this out. We have y less than or equal to negative x. So I know it has a negative slope. So that's this line. So here's the line. That's the line y equals negative x. But if I want y less than or equal to negative x, less than means I'm going to shade below that line. So I'm going to shade all of this over here is a solution to the first equation. All those ordered pairs make that true. And then I'm going to come back in this other one, and I know that this line has to be the other one, but I could solve it to get it into slope-intercept form, which I like a little bit better. So y is greater than a slope of 3/2 x plus 1. So the big thing here is it's y is greater than. So the solution for this red line are all of these. And if you notice, the area that got double shaded is this section R here. So it says, which section or sections could represent all of the solutions to the whole system? R is the only area that represents solutions for both. So the correct answer there is A. All right, number 28 on the free response here. So I have a picture of, it looks like we have a parabola here in blue. And the nice thing about that is that I'm given a couple points. So I'm given an xy of 419 that I know satisfies the equation. And I have 0, 3. And then I have this other line, linear function, that I got some points. I have 0, -9, which is very helpful because it's a y-intercept. And so I have xy's that work for this one as well. So a couple different ways. Let me show you the fastest way that I think you can do this first. The fastest way is, any parabola. Let me just kind of go to the parent function, y equals x squared. When you make a little t-chart and you plug some numbers in here, like if you stick 0 in for x, you get 0. If you put 1 in for x, you get 1 for y. 2 squared is 4. 3 squared is 9. So you kind of have this situation on a graph where you start at 0, 0, and you go over 1, up 1, over 2, up 4, over 3, up 9, and it just kind of keeps getting bigger and bigger. And then when you go negatives, it kind of reflects, and it's the exact same scenario on the left-hand side. Now, I do notice that the parabola over here, this blue one, is pointing down. So to get it to point down, you're going to have a negative in front of the x squared. That reflects it down. So those are just some things that are going to kind of help me out. And I'm just going to check and see if it does follow this 1, 1, 2, 4, 3, 9 pattern. Because if it does, it's going to make this problem a little bit easier. So let me just kind of verify here. If I come over 1, down 1, that would put me at 318. And then if I go over 2, down 4, that would put me at 215. And if I come over 3, down 9, so over 3 would put me at 1, down 9 will put me at 10. And then if I go over 4, which would get me to here, that will be down 16. So that looks like it checks out. So it looks like right here, this move is an over 4, down 16. So that's really helpful. So that tells me that pattern is going to play out on the other side. So we're going to use that fact here in a second. And now I want to focus on the line. And I'm going to do this the long way after I do it the short way here. But let's focus on writing the equation for this red line. Well, remember the slope-intercept equation is y equals mx plus b. Well, right here at -9 is the y-intercept. So I'm going to put that in the b slot. The slope of this thing, the rise over the run, well, we're going from -9 up to -1. So we rose 8 spaces. And we went from 0 to 2 on the x-axis. So we have a slope of 8 over 2, which is just 4. So I now have locked in. This is the equation for the red line. Y equals 4x minus 9. So I'm going to throw that up here. And that should allow me to find some VWs that could work. And so if I kind of keep running this thing out, if I go up another 8, let me just kind of fill in a little table here and let's just get some points. So it looks like the action is happening up in here. So we know it's going to be further than 4 on the x-axis. So if I put 4 in for x, 4 times 4 is 16, take away 9 is 7. If we go 5, that's going to be 4 times 5 is 20, take away 9 is 11. If we go 6, 4 times 6 is 24, take away 9 is 15. And then if we go, I'll go one more. If we go to 7, 4 times 7 is 28, take away 9 is 19. So I have some ideas now of what's going on here. So let's focus on this red line. I now have some points. I know at 4, we're at 7. And the next point I have is at 5, we're 11. 6 is 15. 7, we're up to 19. So right here, this must be at 7, 19. So I know it's before 7. It's going to be either 5 or 6. So I'm kind of zeroing in on one of these 2 points. Well, now let's kind of play with that pattern. You remember that 1-1 pattern or the 2-4 pattern? I think right now, if I go over 1, down 1, that's going to be at 5, 18. Well, that doesn't match up because we had 5, 11. So that's not the point I'm wanting. But this point right here, I think if you go over, so if I can get this out of your way, if we kind of go over 2, down 4, that's going to put me at over 2, down 4. That's going to give me the point that satisfies my parabola, but it also satisfies my line. So I know the intersection point then is 615. So they want to know what is the value of V. Well, V is that X value, which is 6. So the correct answer here is V equals 6. Now that's kind of just an intuitive way. Let me show you the long, hardcore algebra way, the way that a teacher would probably teach you. So let's kind of tackle that one. I'm going to kind of cheat and use the information from earlier. We established that this line was y equals 4x minus 9. You know, I used the intercept. I calculated the slope. Let's find the equation for this curve. It shouldn't be too bad. We can do that. So the equation for any curve is in the form y equals a times x minus h squared plus k. This is the generic form for any parabola. This is what's called vertex form. You want to use this form if you're given the vertex, and the vertex is h comma k. So in this particular problem, my h is 4 and my k is 19. So I'm going to come in here and I'm going to put in some values. Now, what's also nice is I have an xy that I know works. So I should be able to plug all of these letters, x, y, h, and k, to figure out what this a value is. So let's go through and do this. So I have 3 for y equals, I don't know what a is, x is 0. I got both of those from this point. Minus my h is 4, that's my x coordinate of the vertex. K is my y coordinate. And now we have an equation we should be able to solve. So 3 equals a times, well, a negative 4 squared is 16 plus 19. And solving for a, I'm going to minus 19 from both sides. So making this a little bit easier, I'll go 16a instead of a16. When I minus that 19 from both sides, you get negative 16. Divide, divide. So it looks like a is negative 1. Now that was a lot of work just to get this a part. And that was kind of that whole 1-1, 2-4 game that I was playing before. We now know that a is negative 1. Now I'm going to resolve this thing, sticking h and k in there. So that whole first thing was just to get a. Now I got to stick h and k in there. So I'm going to just go y equals -1 x minus h plus k. And this is going to give me a true equation that I could punch into a graphing calculator. So y equals, don't forget my squared here, and I got to kind of crank this out. Order of operations say that I should do this exponent stuff first. So that's going to give me x squared minus 8x plus 16 plus 19. And if you need a little refresher there, that x minus 4 squared is really x minus 4 times itself. So I did first, outside, inside, last, aka FOIL. And that's how I got the negative 8x. Well, now I'm going to distribute the -1 through, which basically just changes everybody's signs. All right, now I gather up my like terms. And I get +3. So here's kind of the whole gist of the problem. I now have written an equation for this blue line right here. Okay, that's the equation for this line. And I also have an equation for the red line. And I should be able to set those two things equal to each other to find this magic point where they have the same solution. So, and this is long, that's why I don't really recommend this method, but if it's all you got, this is what you got to do. So I now can say, well, if y equals this stuff and y equals this stuff, the two stuffs should be equal to each other. And now we can solve this equation, which is still somewhat nasty. This tells me I have a quadratic, so I need to set it equal to 0. I'm going to move everything to the left-hand side. So I'm going to add an x squared, and I'm going to take away this 8x, and I'm going to take away this 3 because I want 0 over there. So I added x squared, I take away 8x, I take away 3. Everything over here disappears. And I have x squared minus 4x minus 12 equals 0. There's a lot of skills in this problem. This is a tough problem because now to solve the quadratic, we need to try to factor. Always my go-to. Could use quadratic formula, completing the square, but I like factoring. Two numbers that times together to make -12, add together to make -4. So how can I make -12? Well, 1 and 12, 2 and 6, 3 and 4. And I got to be careful about positive and negatives. I need 1 negative, 1 positive to multiply to make that. But to add, I think this combination will do it. Those two numbers right here will multiply to make -12 and add to make -4. Now I use what's called the zero product property. If something times something equals 0, either you're 0 or you're 0, and I solve them both. Well, x could be -2 or x could be equal to 6. And in this problem, we know our solution is over here where x is positive, so I also get x equals 6. That's a bear. That's a rough problem. Number 29, free response. In a college archaeology class, 78 students are going to dig a site. So 78 students are going to dig. The site has been divided into 24 sections. So they're breaking the kids up somehow. And each section is going to be studied by either 2 or 4 students. So either have groups of 2 or groups of 4. How many sections will be studied by the group of 2? So why don't we kind of do this? We're going to define a variable. I'm going to use x and y. So let's let x equal the number of 2 people groups. And we're going to let y equal the number of 4 people groups. All right, so I'm just kind of defining variable. You could pick whatever letter you want. Well, let's first talk about sections. We only have 24 sections. So if I take the y section or the x sections and add them to the y sections, we should have 24. So the 2 people groups plus the 4 people groups should be 24 groups. Now we got to deal with this 78 students. Well, there's 2 students in every X group, and then there's 4 students in every Y group. And that comes out to be 78. So our 2 equations kind of represented sections and students. And now we need to solve this system of equations. My go-to pretty much always is elimination. So I'm trying to get coefficients in the front to match up. So I'm trying to get like a 2 and a 2 or a 4 and a 4. I don't see that right now. So I'm going to have to multiply a row by a number to get it to match up. The final question, though, if you notice, says how many sections will be studied by 2 students? So I want to solve for X. So I would not eliminate X here. I would try to eliminate Y. So I'm going to multiply this top row. Everybody in this top row is going to get multiplied by 4. So 4X, 4Y, multiply this number by 4, that would be 48, that'd be 96. So I've now multiplied that row, and now we're just going to eliminate Y's. If I have 4 and 4, I need to subtract to eliminate. 4X minus 2X is 2X. 4 minus 4 goes away. 96 take away 78 is, what's that, 18? And then divide both sides by 2. So it looks like I have 9 groups of 2 people. And I could double check, like let's say that I'm not quite sure that I'm right on this. If I have 9 groups of 2, then that would mean, since I have 24 sections, 24 take away 9, that means I would have 13 groups of 4. Well, let's just check the kids. 9 groups of 2 is 18 students. 13 groups of 4, that's 13, 26, that's 52. Oh, I see where I messed up. This will be 15, because I had to have 24 sections. So these are my sections. So 9 plus 15 is 24, not 9 plus 13. So 15 times 4, that's going to give me 60 kids. And I was getting nervous there for a second that I screwed it all up. So our students check out. Our sections check out with 24. So the correct answer there is 9. All right, 30 and 31. So this is a multi-question problem here. Looks like a physics problem. So I have 3 equations. It looks like I have a v, or velocity or speed equation. I also have a height equation, position, or I have a position speed equation. Not sure what I'm going to need, so let's look at it. An arrow is launched upward with an initial speed. So initial speed is usually v sub 0, v naught, of 100 meters per second. The equations above describe the constant acceleration motion, where v naught is the initial speed. Okay, we just did that. V is the speed, and h is the height. T is the time, and it's probably in seconds, and g is a constant on Earth that's always 9.8 meters per second. So it says, what is the maximum height from the ground the arrow will rise to the nearest meter? Well, just one thing I want to let you know. In general, I've done a lot of these problems on the SAT. In general, there's a couple things you need to understand. When you launch something, or project something up into the air, it follows a parabola. It follows a quadratic. The maximum height occurs at the top of that parabola. Now, usually your time starts at 0, and let's just say that the thing is in the air for 6 seconds. One other fact you need to know is the maximum always occurs at the halfway point. So in this case would be 3 seconds. So kind of always understand that on this x-axis, the maximum height's always going to be in the middle of, when it takes off and it hits the ground, it's always in the middle. So I think that's going to probably come into play on this problem. So let's actually get into it and let's kind of see what's going on. So I'm going to use this equation up top, the height equation, because they want to know when is the maximum height. So H equals our V0, our V sub 0 or V naught there is 100. That's the initial velocity. We don't know T right now. And we have minus 1/2. G, they told me, gravity is 9.8. And that's T squared. So we have an equation here. And we're trying to find the maximum height. Well, a couple things that we know from what I just told you a second ago. When you have a graph, the two heights that we're interested in, so this is height, this is time. We're interested, it leaves the ground at h equals 0, and then it's going to reach its, and time equals 0. It's going to reach its other spot over here. It's going to hit the ground at some other time. So we're kind of interested in the two places where the height is 0. That'll give us our start and our finish. So I'm going to solve this equation when the height equals 0 and try to find these two numbers. Now, I know one of them occurs at 0 seconds. This is the one that I'm curious about, to find the other solution when h is 0, because I know there's two of them. So let's get after this. This is 100t minus half of 9.8 is 4.9 t squared. So we're solving a quadratic. The nice part here is there's no constant. So I'm going to factor a t out. I'm going to yank a t out of both of these. And I'm going to do 100 take away 4.9t. Basically, that's like the reverse distributive property. You know, the distributive property says this should equal this number, and this should equal that number, and it does. So factoring is just doing the opposite. Well, now I can use the zero product property, because I have something times something equals 0. So either time equals 0, which we already knew that one, that was this one. The other one I'm interested in is when is 100 minus 4.9t equal to 0? So we need to solve that. So I'm going to move the 4.9t to the other side. I'm just adding 4.9t to both sides. And I get that. Divide by 4.9, divide by 4.9. And let's see what we get here. I get 20.4. Now, what that means is, that means that on this graph, this arrow shoots up in the air, it comes back down. It took 22 or 20.4 seconds to start from the launch and then hit the ground again. So I know when this maximum is going to occur. This maximum is going to occur exactly at the halfway point. Okay, right there. So what is half of 20.4? So if I chop 20.4 in half, I get 10.2 seconds. So 10.2 seconds is the halfway point, which is going to be right there. So at 20, check that, at 10.2 seconds. And now I need to figure out, well, what is the height? So what I can do is I can go back to my original equation. All right, all the way back up here. And I now have a t to plug in that'll tell me what the h is. So I come here, and what is the h at exactly 10.2 seconds? So I just substituted that halfway point in for t. That should give me my h. And I put all this into the calculator. Doom, doom, doom. And it looks like the height, I got a height of 510 feet. So that would be the correct answer for number 30. I've already answered number 31. Number 31 says, how long will it take for the arrow to reach its maximum height? Well, that's going to be right here at 10.2 seconds. So that was kind of a 2-for-1 special. Actually knocked it out. Now, you guys with a graphing calculator, at the very beginning of the question, you could have, and I'm going to go ahead and just erase this. If you have a graphing calculator, you have a huge advantage. because the graphing calculator, as long as you plug this equation in, it would graph that thing for you, and you could zoom in and calculate the max, and then you could get the height and the time right off of either the graph or off of the table function. Most graphing calculators, you have your y equals key that you punch in, and you would have punched in, the equation y equals, instead of h, we're using y equals 100. You're going to need to use x on the graphing calculator instead of your t, minus 1/2 times 9.8 x squared. If you enter that graph in, you'll get your little sketch of the graph. And then if you want to, over here where it says graph, right above there is table. If you do second table, it will give you the x and y coordinates. And you would find there on the graph that at 10.2, this would be the highest position. The numbers would get smaller and they would get smaller. So this would lock in your max. So the problem would be much faster with a graphing calculator.